All right. Thank you, Dr. Woodworth. And it is a pleasure to be speaking with you again today. And it's really been a great opportunity to be a part of the feed safety team. I've been working with them now over the past year and have really learned a lot. And what I'm going to kind of talk to you today is our 50,000 foot view of what is feed safety and how do we address it. And it really comes down to 5 essential steps. The first thing you have to do is determine if an ingredient or feed stuffs is likely to get infected. If it can get infected, can that pathogen survive? If it survives, is it infectious? Will the animals actually get sick? And then how can we prevent this from bringing these pathogens into our meal? But if we do fail at prevention, how can they be mitigated? And so each one of these steps is where we kind of focus some of our core research questions and determine what projects we're going to do here at Kansas State to help answer these questions. And remember, they're going to be pathogen specific as well as species and other things as well. So a lot of our work has been focused on swine. Initially we started out with the PED work, and as Cassie or Dr. Jones will mention today, some of our recent work with ASF. So we're really excited about those results. But the first thing we have to determine is a feedstuffs or a complete feed likely to get infected. And so what determines that risk? When we're thinking about risk of pathogens contaminating ingredients, what do we need to be thinking about? And first, you need to identify the geographical locations. Is there any kind of pathogen or disease outbreak within a certain region where you're purchasing ingredients from that could likely contaminate those ingredients? Then the next thing you have to consider, okay, if that is the case, what are the agricultural practices? Is that pathogen coming down the road on trucks and potentially contaminating grain that's being dried out on the street? Or is that pathogen in wild boars that are then dying in the fields and getting caught up in the combines? Okay, so there's different ways that that can be spread. And then the next question is, if that pathogen can contaminate those ingredients or be brought into the mill, what does that mean? And so in order to identify the risk, you have to think about those kind of things. What are the different ingredients? Are they coming from countries or areas that have ASF, classical swine fever, foot and mouth disease? Or is there something within your area that you need to be concerned of with different types of pathogens that aren't necessarily transboundary disease? In terms of lower risk, there may be ingredients coming from certain areas, but are there certain practices in place that help reduce that risk? Doing things like packaging in individual single-use bags. Are you incorporating quarantine times before those ingredients can be moved? Other things of that nature. So once we've determined if it can infect ingredients, then the next step is, what's its ability to survive? And really what we've learned is that there's a lot of different pathogens that act differently or survive for different lengths of time and different ingredients. So it's really something you have to take on a case-by-case basis to understand what pathogen you're dealing with, what ingredients you're dealing with, and what their survival rate's going to be. A couple of observations that we've come up with over the years throughout our research is that the ingredients that tend to harbor virus have a higher protein content. So our protein sources are more likely to harbor virus. Those porcine-based ingredients, ingredients that have relatively large surface area to mass ratios. So when we're thinking about soybean meal that has been processed, increase that area to volume ratio versus the whole soybean, and potentially provides more exposure to that protein, that pathogen is likely to survive longer. And then also thinking about micronutrients that have carriers. So those carriers could potentially allow those pathogens to survive. So the next step in this process is to determine if it's infectious. And this is when we really rely on our collaborators. We really appreciate the help of those who've worked with us at different universities or over in the vet school here at K-State, whether it's Dr. Rick's labs or others. But really, When we're trying to determine if it's infectious, it's going to depend on the virus. It's going to depend on, which will depend on how much virus is needed for the animal to get infected and other things of that nature, but something we're constantly learning and trying to determine. So our key steps, and this is when I get really excited about feed safety and thinking about how does it relate back to the feed mill. What kind of practices are we incorporating at the feed mill, or what can we improve upon to potentially prevent bringing that virus in? And so our goal is to really eliminate contamination from trucks or people. Okay, those are the main sources we've learned throughout some of our observational research, that if you have dirty truck tires or people with dirty boots walking through your mill can potentially bring that virus in. And there's some things we can do to help prevent this from happening. Some of those things are things like using receiving mats or funnels, so preventing any of that material that you're going to bring into your system from contacting the dirty surfaces on the outside, or when the truck drives over, preventing any fecal material from the truck to fall into your receiving pit. The other thing is, when possible, don't let drivers out of the truck. So if you can either direct that foot traffic or have the driver stay in the truck, that'll also help reduce your risk of bringing virus in from or pathogens in from the outside world into your mill. And have your employees do as much as possible to unload and really start creating that culture similar to what we've done on the farm in terms of biosecurity. Another example, this picture here, we have our hand ad station. And notice the spillage of the ingredients. That's the easy opportunity. You have this broom on the left side to sweep that in to your hand ad station, and that could potentially be contaminated now that it's on the floor. So just doing things like having a raised hand ad station, which kind of reduces that temptation to sweep product into your receiving pits and potentially contaminate your final feed. Now, if we're not able to prevent it, or we want to add a layer of risk reduction, there are potential feed mitigants that can be added. But the one thing we have to consider is, as you look at different viruses, they have different properties about them, and mitigants are going to act in different ways. So we really, you can't just add one mitigant that is going to be the same across all viruses. So we need to make sure we're continuing to learn how mitigants act for each virus in different ingredients and things of that nature when we're trying to determine what's the best mitigant to use. And this is some example of some of the initial research we did, and this is in complete swine diet, so complete feed. And remember, the CT values, the greater the value, the less virus that we're quantifying, or the RNA of that virus that we're quantifying. So you can see here, as we added medium chain fatty acids to the diets, we reduced the PED quantification by PCR in the complete feed. Okay. And then also the other thing I want to point out is, notice as we increase the time, those CT values or the amount of virus reduced as well. So there is a time component that can influence how much of that virus is found in the feed. From a porcine meat and bone meal standpoint, so this is now a specific ingredient. And remember, we said porcine products, high protein. Notice our CT values, we didn't see as great of an effect using in-feed mitigants against those, against PED. Also notice over time, the virus CT values stay relatively low and didn't increase as much over time like we saw in the complete feed. So once again, we have to think about, okay, what are the ingredients? What's the virus we're dealing with? What are the different mitigants we have the potential to use? And take all those things into consideration when we're making decisions. The next thing we want to think about is the surface type. So this was, we collected, or we had contaminated dust that we put on a lot of different surfaces, whether it was cement, plastic, rubber, stainless steel tote bags. Notice those CT values did vary some, with a lower CT meaning more RNA of that virus on the rubber and stainless steel compared to the tote bags. But all of these surfaces did harbor the virus. We were able to swab and measure that virus there. So something to think about when we think about moving feed through a feed mill, all of our different surfaces and how dust collects on those surfaces and the ability of virus to survive. So in conclusion, this is just really a quick overview of some of the things we've learned over the years. In our stepwise process, we look into for assessing feed safety. And really remember, feed is just one of the many potential vectors of pathogens. Some of the key things we can do is exclude high-risk ingredients from high-risk countries, improve our supplier communications. Knowing your supplier is very important from not only a feed safety, but quality concern. Also starting to think about biosecurity, creating that culture around biosecurity within your feed mill, getting buy-in from your managers and your employees to think about it like you do on the farm basis. Consider feed and environmental testing to learn more about if your facility is contaminated, is there something you need to do to address that? And also considering when the time is right, if the risk is high enough, do we need to use proactive mitigants? So with that, I am now happy to turn it over to Dr. Jones, who is going to present on some of the new feed safety research we've been working on. Thank you.